this video, we want to talk about how you can easily calculate the molar mass of a chemical using like some stoichiometry. So we're going to take a simple reaction. We're going to take M plus hydrochloric acid, HCl, and it's going to make MCl2. We're going to learn something. The metal had a charge of +2, and of course kicks out hydrogen gas. Now we need to balance this reaction, right? Now M isn't a real, it is a real chemical, and there'd be 2 hydrochloric acids when we balance this out, right? Yeah. So this is a reaction. And what we've got here on this problem is, let's say that we start with 2.35 grams of the but it produces 0.598 liters of hydrogen gas. The question, what is the molar mass of the metal? Or actually, more specifically, what is the metal? Now, let's recall, what is molar mass? What does that mean?
So molar mass is always grams divided by 1 mole of that thing.
So I already know something about this metal. I know it's grams, it's 2.35. So if I knew it's moles, I would simply take 2.35 divided by the moles. And if I'm trying to figure out what it is, I can just look on the periodic table. There's a molar mass of 23, for example. It'd be sodium, because molar mass has a molar mass of 23.
By the way, I wrote 1 mole in here. That's the typical thing if you're looking on your periodic table, it gives it per 1 mole. But our job here is this: if we know the grams, we're going to use the information on our table to figure out the number of moles of this M, and we're going to put the number of moles in here. When we divide it out, it will be per 1 mole, but just be aware that we have to solve for moles.
And this isn't terribly hard. We're essentially going to just convert the liters of this to the moles of this, and then divide. So we start with what we, so that's, question mark, and once you put moles next to that. So we're trying to solve for the moles of that, and this is our given amount over here of hydrogen gas. Yep, arrow, excellent. So start down here and write 0.598 liters of hydrogen gas over 1. And we're going to convert from liters to moles first.
And by the way, again, he's not, I don't know if you mentioned at the beginning, but this has to be happening at STP.
Yep.
Or else this doesn't work.
And then you'll take 22.4 liters in 1 mole. Actually, there are ways non-STP to do, but we'll learn about that later. And then the liters of hydrogen gas cancel. And I'm going to go from moles to moles. In this case, it's easy. It's a 1-to-1 ratio, right? There's 1 mole of hydrogen gas on the bottom to 1 mole of metal. I then get my trusty calculator out. I'll take 0.598 divided by 22.4 times 1, whatever. I get 0.0267 moles of the metal. Now, I want to find out what it is. So I can just take 2.35 grams, this is easy, divided by my moles. So 2.35 divided by 0.027, and I get 88 and some change. We'll just call it 88 grams per mole. So when we look at the periodic table, you might say, wait a second, we've got, I'm looking, strontium has a weight of 87, and yttrium has a weight of 89. And so it's kind of in between. So which one would you choose, Mr. Dimitrievich?
Well, in this particular case, we know that this is a metal, right? And we know that it has a +2 charge.
Ah, that's a key thing, the charge.
So because it's in +2, and we don't know what yttrium's charge is, we know that calcium is, and we take a look at the periodic table here, we're magically popping up on the screen, it's going to be a +2. Yeah. Therefore, this is likely to be calcium.
Strontium, you mean.
And by that I mean strontium, because that heavenly words are hard for me.
Yeah, it's SR, which is a molar mass of 88-ish. So sometimes when you get these types of problems, the numbers won't perfectly work out, but if you know the charge, that's one more piece of information to get it done. So that's how you do molar mass problems. We'll see you in class.
Indeed.